Okay, so we're going to start, because I want you to understand why this works. I don't want to just throw some magic rule at you and say, when you see this, you do this. If you understand where it comes from, hopefully it'll make a little bit more sense. So we're going to do a little chart. And the whole idea here is, although with exponent situations, we could expand stuff out and really look at what that means. The point is, they don't want you to do that. They want you to understand when you get, you know, a couple things that have large exponents, the rules are actually going to shorten up what you have to do and make things easier, okay? They're really kind of shortcuts. But when we look at 2 to the third, remember, that's actually 2 times 2 times 2, which is 8. And 2 squared is 2 times 2, which is 4. And 2 to the first is just 2. So we have that. You're going to get into that imaginary 1 that is sometimes there and sometimes not, right, Tino? Writing this down. Okay, so that is just 2. And here's where we get into the area where people are not always as comfortable. 2 to the 0, quite often people want to say, well, that's 0. It's not 0, because there's a pattern here, okay? If you look at every time I decrease my exponent by 1, I'm dividing out that base. The base being 2, right? 2 is the base, 3 is the exponent. But if I decrease it by 1, I'm just dividing by 2. So if I keep dividing by 2, then what would be the next number in this pattern? 1. So 2 to the 0 is really 1. And not only is 2 to the 0 1, 5 to the 0 is 1, b to the 0 is 1, 2.879 times x squared y to the 5th, all to the 0 is 1. Anything to the power of 0 is 1. And it's because of this pattern. Okay, does that pattern make sense? Sure. Now, if we take the pattern further by subtracting another number off of our exponent, we get into a negative exponent. 2 to the negative 1 is not negative 2. Negative exponents do not become negative bases. Applying the pattern, if we divide by 2 again, then 1 divided by 2 is actually 1/2. So the step in between is to say, well, hey, all that happened here is that negative exponent became positive when I moved it to the bottom of a fraction. Okay, and if I divide 1/2 in half, again, it's 1/4, and this would be 1/8. So you're seeing the pattern. Now if we go back to what happened with the exponent, 4 was really 2 squared, right? So this becomes 1/2 squared. And this becomes 1/2 cubed, right? Because we just keep dividing by 2, but this is equivalent to that. So we've got 2 rules here that you're going to learn and use to simplify, because there's a whole bunch of things in math, kind of like when they say, no, can't have 0 in the denominator of a fraction, right? You learned that one hopefully long ago. You can't divide by 0. right? There's more rules that we're going to throw in there and say, hey, you can't leave a 0 exponent. It's not totally simplified. And you can't leave a negative exponent. Both of those are trouble. Okay? So we have
scientific notation is negative. It's negative this way and positive.
Yeah. That's different though. That is one occasion, scientific notation, you can have negative exponents, but that's the only time. Any other occasion where you have a negative exponent, you need to simplify the expression, which is what we're learning today. So, the two new rules would be a to the 0 power, and a could be anything. Okay, a to the 0 is 1. Doesn't matter how complicated that base is, whatever has an exponent of 0 is 1, which makes it nice, because as soon as you see that 0, like, woohoo, that's a 1. Now, the other part of it, so this is one of our rules, the very first one. The second one is a to the negative b. We're just going to use, that way a could be any integer, b could be any integer, a could be a decimal for that matter. But to get rid of a negative exponent, think of like an elevator, okay? This is really the top of a fraction, right? If I have something in the top of a fraction with a negative exponent, I put it on that elevator and I move it to the bottom, and that changes my negative exponent to a positive. Works the same if I had something in the bottom of a fraction and I want to get rid of a negative exponent, I would move it to the top. So that simple switch changes the sign on my exponent. So this would be 1 over a to the b. And we'll do some examples so you can see how to apply that in different situations.
What if the actual number is a negative?
Then we'll have to talk about what if the negative is in parentheses with the exponent, then it gets the exponent. If not, only the base itself gets the exponent. So we'll do some of those too. All right, so keeping those rules in mind, we're going to do some examples.
This is the only thing we're doing today?
0 negative exponents, yes. And evaluating. You're going to do a little bit of evaluating. But so say I have, because we're going to deal with numbers and variables. Okay, say I have 4 to the negative third. We do not evaluate with a negative exponent, ever. You get rid of the negative first, so we apply the first rule and say 4 to the negative third is the same as 1 over 4 to the third. And then, kind of a general rule of thumb, if it's small enough, you know, that you could easily do 4 to the third, then we do 4 to the third. Occasionally you have really big ones and we'll just leave them with that exponent. But in this case, we can do 4 to the third. Nope, should be bigger than that. Because 4 times 4 is 16 times another 4.
4 times 2 times 4.
Should be 64, I believe. Yes. So that'd be 1 over 64. So you take care of those negative exponents first. And that was from our pattern. Remember, those negative exponents, when we move them to the bottom, they become positive because we've divided by 4 basically 3 times, which gets us here. So let's try another one. Okay, so there's that 0 exponent. which just makes that 1.
Could it be negative or one, or just one?
The only time this would be -1 is if I threw a negative out front. Because that's what I was talking about earlier. This would get the exponent, but that negative would not. There's a couple instances where you really have to watch where the negative is. If there are parentheses, if it's in, gets the exponent. If not, the negative stays. If there are no parentheses, and we'll do one of those too. So there's a difference here, and we're going to do these kind of at the same time. Okay, so we're going to do -2 to the 4th and -2 to the 4th, because this isn't really our exponent rules, but we need to talk about this before we apply the 0 and negative exponents. Okay, so this is just old stuff, but we're going to kind of look at these together. This means -2 times -2 times -2 times -2. That's why it gets the exponent. It's in parentheses. That means I have 4 negatives, right? Each pair cancels out. So ultimately, any even exponent, if my negative inside gets it, it's going to be gone. Because this means I have 4 of them, right? So this is really just 16. What's the difference here?
-16.
Only the 2 gets that exponent. This is pretty much like saying the opposite of 2 to the 4th. That's the difference. So that negative does not get the exponent. So this would be -16. Parentheses will contain a negative, and then you apply it. Lack of parentheses mean that's like a -1 in front. Okay? So you wouldn't apply the exponent to it if it's not in. All right. So now, if I did, let's look at this. So now I've got a negative base and a negative exponent. These two don't cancel each other out. They're totally different things going on. We're going to deal with that first, yes. This would be 1 over -3 squared. Now technically, you could just put that negative out front because it's a situation like this, right? Your negative is not going to get squared, right? Because it's not in parentheses. So this would be 1 over -9. And as long as you only have one negative, the whole fraction is negative, right? So we could list it like this, or we could just say that's -1/9. Just put the negative in front. The point is, the negative does not go away because it's not in parentheses with that 3.